Okay, quadratic functions. We're going to start with the equation of a quadratic function, which is going to be in the form y equals ax squared. That's the important part. That's what makes it quadratic. Plus bx plus c, where a, b, and c are constants, and a is not equal to 0, right? Because we need an x squared. Otherwise, it's not quadratic. So let's take a look at these and say, yes, they are, or no, they aren't. Is this quadratic? Yes.
He has a talent.
Yeah. Oh, trust me, I know. You're lucky if you got like 20 extras. So. Is this quadratic? No. Why not? It's got an x cubed, right? So what is it? What's the name? So this is quadratic. This is cubic. Is this quadratic? Yes. Okay, because if you multiply it out, you're going to get an x squared, right? And you won't get an x cubed, which is this quadratic? No. Why not? Because this is 5x to the negative 2, right? And to be quadratic, you have to have an x to the positive 2. Is this quadratic? No, because of the root x. Right? So the root x makes this not a quadratic equation, right? You can't have a root x because that is x to the 1/2. Right? So the whole thing. Why? Because you get an x to the half. Right? You can have an x squared, you can have an x, you can have a constant term. Can't have an x to 1/2. Okay, the graph of every quadratic equation is called a okay, yeah. Whichever we say parabola, right? You could say parabola. So it's a parabola. The point where the parabola changes directions is called the ooh. Okay, called the vertex. Now notice the parabola can open up or down. The parabola may open down, in which the vertex, so what's this point then? It's going to be called the maximum, right? It's at the top. You're not going to get any bigger than that, so it's a maximum point. Or the parabola may open up, yeah, in which the vertex will be a minimum point. The vertex can be found using the TI 83, 84, or whatever, or Casio if you have one, or by selecting second calc and selecting. We just did we do one yesterday? Yeah, okay. So what do we select? We select maximum or minimum. Axis of symmetry. The parabola is symmetrical about the axis of symmetry, which is what kind of line is this?
Vertical.
Vertical line. Yeah, it's straight, but all lines are straight. That's what a line is. That passes through, where does it go through? The vertex. So if you've drawn the parabola on paper, it just means you could draw a vertical line through the vertex, fold it in half, hold it up to the light, and all you're going to see is one line, right? Or you could put a mirror here, and if you look in the mirror, you'll see the reflected image of what's on the other side. Okay? So that's the axis of symmetry. The vertex parabola is PQ, so we're always going to say that. The vertex is at the point P, comma, Q, right? When we're talking a general quadratic. Some books will use H and K, so if you're looking around or on the internet or something, you might see H, comma, K, but we use PQ. So what's the equation of the axis of symmetry? So this is the point PQ. We get a vertical line, has an equation of, think back, Tennessee, a while ago. So, what's this point going to be? What's the x-coordinate of that point? P, comma, something. Okay, what's the equation of that line? X equals P. Yeah, so every x-coordinate on that line has a value of P. The y-coordinates vary. Okay, what's y? It doesn't matter, right? What matters is that x equals P. So that's the equation of the axis of symmetry, right? You always have to write it as an equation. Needs to have an equal sign. Needs to, being as it's a problem, needs to be x equals, right? So it's always, if you're asked for the equation of the axis of symmetry, you just write x equals P. What's P? It's the x coordinate of the vertex. Okay. Domain, it's a good time to break. Okay, domain and range. What's the domain for every quadratic function? Domain. So what is possible x value? Or what x value could you not ever put in there?
Zero.
Can't put 0 in for x in like 2x squared plus 7x plus 12?
Would it be anything under the vertex?
Well, wait a sec. I think you're talking range now. So domain, is there any x value I can't put in? Any number I can't square? Can I square pi? Can I square negative 300? Can I square negative 1 billion? So is there any number I can't square? No. So then the domain is? Every number. Okay, so how do we say that? X belongs to the reals. Okay. So that's kind of short form. There's a more formal one. It might look like this. I'm okay with this, right? That's fine, right? I mean, we don't need to. The formal one just says the set of, that's the brace bracket, is the set of, okay, the set of what? The set of x. What about them? The vertical line means such that. So that's right, the set of all x such that x belongs to the real. The range will depend on whether the parabola opens up or down, right? Range is the y values. So if the vertex of the parabola is PQ and the parabola opens down, okay, so here the vertex is at PQ and the parabola opens down, then what do we say about the range? Everything below Q. Does it include Q? Okay, so the range is y is less than or equal to Q. If the vertex of the parabola is PQ and it opens up,
Where do we go for the books?
learning commons, the central desk. Then the range will be
Greater than or equal to Q?
yeah, y is greater than or equal to Q. Okay? So again, just take a look here. Right, any value bigger than Q if it opens up or equal to, and any value less than or equal to Q if it opens down. So if it's a maximum, all the values have to be below or equal to it. If it's a minimum, all the values are above or equal to it. The y-intercept is the y-coordinate of the point where the graph intersects the y-intercept, y-axis, right. Uh-oh. Anytime we get the thin writing, it's going to disappear. We'll talk about it. I'm not going to write a whole bunch more. After it disappears, I'll rewrite it. Then we'll see. Don't ask me why. At this point, the value of the x-coordinate is always 0. Okay. The y-intercept can be found using the TI-83 calculator by selecting second calc, then number 1 for value, and then typing in x equals 0. Actually, all you're typing in is the 0, right? Because the calculator is going to say x equals, you just put in 0. If the equation of a quadratic function is y equals ax squared plus bx plus c, then the y-intercept is equal to
C.
c. Yeah? Put a 0 in here, becomes a times 0. Put a 0 in here, it becomes b times 0. 0 plus 0 plus c, so it's just c. Okay, so y-intercept occurs when x equals 0. You want to find the y-intercept? Put 0 in. If you've got the equation, put 0 in. You just look. If you got the equation, you just say, oh, it's the constant at the end, right? X-intercept, or intercepts. The x-intercept is the x-coordinate of the point where the graph intersects the x-axis. So one big thing to remember about intersects or intercepts is they're just a number. So if I ask you for the y-intercept, don't say it's 0, 3. Don't give me the point. Just say the y-intercept is 3. Okay, it's just the value of the y-coordinate. And the same with the x-intercept. Right? Don't say, oh, that's at 5, 0. Just say the x-intercept is 5. Okay, just a number. At these points, the value of the y-coordinate is always 0. Okay, so this will be at x, 0. Actually, this is 0, y. Right? That's the coordinates of the point are 0, y, or x, 0. The intercept itself is just the x or the y value. The x-intercepts are also called the zeros of the function. Right? The zeros of the function. In other words, they're the value of x that will make the function equal to 0. The x-intercept can be found using the TI-83 calculator. Is fine. That makes sense. How's that? By selecting second calc and then using 0. Okay? There's also another way, which I like better. And the other way is to graph y2 is equal to 0. So you're actually going to graph this line. And now you have two lines and you find the intersects, right? Second calc intersect. Now the reason that's easier is if you're going to do second calc 0, it's like finding the max or the min. Okay, it asks you, what's a left value? I want some place to the left of the 0. I want some place to the right of the 0, and then I want your best guess, right? So you're always just sort of, moving around. To do an intersect, we just move to the point, right? Second calc intersect, move it to the point, hit enter 3 times. Right? That way you don't have to worry about left bound, right bound kind of thing. Either one works out, doesn't matter. Examples, for each function, determine the following. Round all answers to the nearest tenth if necessary. Okay, first step, we want to graph this. Okay, so let's pull out our calculators and hopefully turn on. Come on, really? All right, I'm just going to have to kill this and restart it, so hang on. Okay, so one nice thing about this is you'll actually see the key hits, right? If you're playing it back, you can see the key hits, and so if you're, what did you do there or something? So we want x squared. Now when you hit the squared, it just jumps down onto here, right? Sometimes you have to watch out. If you use the caret to go up and enter something, it'll stay up there, and all of a sudden you've entered everything up in a superscript. Okay, so just, check and make sure that stuff is going in where you want it. And especially if you hit graph and something weird happens. Okay, so hit graph. Now we're just using the standard window. Okay, which is good enough, right? And that's what they're giving us to sketch on. So we're just doing a sketch of the graph. It doesn't have to be totally accurate. I mean, okay, but it should resemble reality somewhat. Okay, so there's the graph. What else are they asking for? The coordinates of the vertex. Okay, how do we find that? Count, but is there a way? What's the vertex? It opens up, so the vertex is a minimum. So second calc. Whoops, just the second. Second calc. Minimum 3. Now wants a left bound, so I'm just going to move a little closer. Enter. Right bound. Just need to go up to the right. And a guess. And so what's 2.999999992? 3. Okay, that's 3, right? So this is 3, and that's a -1, right? It's a little tough to see the negative there. So that's 3, -1. Now, vertex is a point, so what do I do with the 3 and the -1? You put brackets around it, right? Indicate that is a point. Otherwise, it's just a list of numbers. What's the equation of the axis of symmetry?
X equals
x equals 3, right? Remember, x is the axis of symmetry goes through the vertex, and this is p. X equals p, so x equals 3. What's the domain of every quadratic? It's actually every polynomial function, but x belongs to the reals. What's the range?
X is greater than negative. Or y.
So y is
Greater than or equal to negative.
greater than or equal to -1. What are the x-intercepts? Well, we're gonna need this now, right? It looks like 2 and 4, but okay. So here's what I'm gonna do. Well, actually, I'll do one each way. So okay, I'm gonna graph y2 equals 0, and then just hit graph, and I'm gonna do one as a 0 and one as an intercept, right? So just so you can sort of see the process. So second calc. Okay, number 2 is 0. Left bound, so you see what it's saying? It's go to the left of the 0. Okay, I'm to the left. Go to the right of the 0. Okay, I'm to the right. And then give me a guess, right? Since there's 2 zeros, you got to tell basically which one you're looking for. Enter. And it says 2. Okay, so the x-intercept is 2. We're not interested in the 0, right? We say the x-intercept is 2. And what's the other one? Okay, so let's do the other one. Second calc, intersect, number 5. Because I have 2 curves, right? So I'm just going to move about to the other point there and hit enter. 1, 2, 3. 3. Okay, and it's 4. Okay, so the x-intercepts are 2, 4. Okay, do I put brackets around those? No. Okay. You could also write 2 and 4. And what's the y-intercept? Don't need the calculator. Just look at the equation. What's y-intercept? 8. Right? Okay. Questions? Okay. You do this. You got calculators? Or somebody you can look on with who has a calculator? Okay. Y equals. All right, so we have an equation, we graph it, and we're missing something, right? We're missing the point up here. And it's fairly narrow, so I don't really need to go -10 to 10, right? Maybe I'll go, let's say, what? -3, maybe to 5, and we got to go higher. So how high do we have to go? So I'm in negative 10. I could leave it at -10, but really the interesting points are kind of above that. So -5. Now 15, what's 15? What do I know about 15? It's a y-intercept, right? So that's probably not where it maxes out. So let's go a little bit higher than 15, maybe 20. And let's go by 5. Okay, and I think I messed up my y. I wanted to have. Yeah. Okay. So y min, yeah, -5. Hey. Problem out here is depending on how I hit, I either get the key or I put a little dot there. Okay, that's better. Okay, nice graph. Whoops. So let's move over here. So what's that look like? Okay, and there's the axis. -3 to 5 by 1. Okay, so putting a scale in there just gives us somewhat of an idea, right? But I mean, again, all right, so coordinates of the vertex, we're going to need to find the max. So go back to the graph. Max is 4. Left bound, so I got to go down here a ways. Right bound. And a guess. And we get 0.8 and 18.2. So we can label that on here if we want. We can also kind of sketch in the axis of symmetry and write its equation if we want. You know, putting down some information can't really hurt. We already know this is the y-intercept is at 15, and we don't know the x-intercept yet. But equation of the axis of symmetry, x is 0.8. Domain, it's a quadratic, so it's all real numbers. What's my range? Y is less than or equal to 18.2. Okay, x-intercept. Well, definitely have to go to the calculator. Second calc, so I'm just going to use intersect. And what I can do is move down to the straight line, right? So y1 is my quadratic, and y2 is my line 0, right? So it's easier to just move along this line. If I hold it for 3 seconds, it takes it as a right click, so I gotta like let off every. And then just hit enter 3 times, right? Okay, we get 1.1. Oh, sorry, negative 1.1. Okay, remember that. Second calc intersect. Okay, again. Now, see, what I don't want to do is trace along this, right? Because I got to go all the way up and all the way back down. So let's just move down to the line. Hold for somewhat less than 3 seconds. You don't have to do this on your calculator. You can just hold it. And get there, and then 1, 2, 3, and 2.7. So negative 1.1 and 2.7. Y-intercept, 15. Okay, remember, they're just numbers, not points. Don't write down the y-intercept as 0, 15, 0, 15, right? Okay, any questions on this page? Given the following information about various quadratics, various quadratic functions, sketch a graph of the function and complete the following statements. Okay, so now the idea is we're giving you some information, right? I'm saying the range is y is less than or equal to 4, which means the parabola opens down, right? Because it means that's the maximum point, so everything has to be less than that, down. The parabola has blank x-intercepts. Okay, so we know that y is less than or equal to 4, right? So that means the vertex is like somewhere up here at 4, and we open down, so what do we got to have? 2 x-intercepts. Okay, so if you what if it opened down, but it was y was less than or equal to negative 4? How many x-intercepts? None, right? Because it would open down, it would be below the x-axis, be no intercepts. Okay, the vertex is at 5, 1. All right, let's put a vertex at like 5, 1. The parabola also passes through the point 2, 3. 2, 3. Okay. Okay, which way does it open? It opens up, right? So the parabola's got to look like this. So So it opens up. How many x-intercepts?
0.
0 x-intercepts, right? It opens up, and the vertex is above the x-axis, so there's no intercepts. The equation of the axis of symmetry is
X equals 5.
x equals 5. Remember, x is equal to the x-coordinate of the vertex, the equation. Another point the parabola passes through is
8.
8, 3. So how do you get 8, 3?
Symmetry.
Symmetry, right? Yeah. So how far away is this, right? From 5 to 2, if you go 3 units to the left, you're up at 3. So that means if you go 3 units to the right of the axis of symmetry, right? So by symmetry, if I fold this over, it's going to be 3 units over this way, which puts it at 8, and the same height, 3. All right, the x-intercepts are -5 and 3. Okay, so -5, whoops, not very well. -5, 3. The range is y is greater than or equal to -2. Okay, so we've got -2. So which way does the parabola open? Up, right? Because it's got to be above here, and it has x-intercept. Parabola opens up. What's the equation of the axis of symmetry? -1. Now, can't just say that. What do you got to say?
Equals minus
X
one.
equals negative. Now, how did you get x equals -1? Symmetry?
-5.
Yeah, so we know where is it? Well, it's got to be halfway between the x-intercepts, right? So what do? We go, x equals -5 plus 3 over, so we say for the axis of symmetry, which I'm just saying A of S, we know that x equals -5 plus 3 over 2, which is 2 over 2, and x equals 1. It's -2 over 2 and -1. That's thinking 1, that's not very symmetrical. So there, -1. Okay, so there's my axis of symmetry. Where's the vertex? -1 and -2. Okay, so we found the axis of symmetry. There's a negative there. Found the equation of the axis of symmetry. That gives us the P, right? Gives us the x-coordinate of the vertex, which is P. And then the Q, well, that's Q, right? Y is greater than or equal to, so we've got PQ. So here's the vertex, here's the parabola, and this is the point, -1, -2. Right? So given information about it, right, we can come up with a fairly accurate sketch, right? We can put it all together. All right, the quadratic function y equals 3x squared plus bx plus c passes through the points 1, 2, and -2, 26. Algebraically determine the values of b and c. Oh, okay, how are we going to do this?
We can find C by making the y-intercept x equals 0.
We don't have the x-intercept though, right? We just have these 2 points.
Yeah, we can find the y-intercept with x equals 0.
Oh, yeah, okay, so we got y equals c, but
we can put the two inputs inside the equation.
yeah, so what is 1, 2? It's a quarter, right? It's an xy. So for 1, 2, let's take y equals 3x squared plus bx plus c, and let's put that in, right? So y is 2, and x is 1. Okay, right? So remember, this is the y, this is the x, this is the y, but the y gets written here. So it's 2 is equal to 3 times 1 squared plus b plus c. So 2 is equal to 3 plus b plus c. So what's b plus c equal to? -1. Okay, now, what's the other point? -2, 26. Okay, we're going to get 26 equals, right? So I'm just sort of carrying down from this. That's still in effect. So the y is equal to 3 times negative 2 quantity squared plus b times negative 2 plus c. Right? So we know that what's true is the y is equal to 3x squared. So those points have to satisfy the equation. They have to make it true. So now we get 26 is equal to 12. Anybody mind me writing 12? I mean, I could go 3 times 4, but that's 12, right? So minus 2b plus c. So we can do this as what? We got a couple of choices. We want to write it kind of in this form, right? So we could go negative 2b plus c equals, or we could go 2b minus c. Let's do that. What if I go 2b minus c? What's that going to be equal to?
Minus 14.
Minus 14, right? So here's what we're doing. We're going to move this over here. It's going to become positive 2b. We're going to move this over here. It's going to become minus c, right? We're going to move this over here, where it's going to become minus 26. It's going to be 12 minus 26 is negative 14. Okay, everybody good with that? A lot going on, stuff switching sides and that. Okay, you could also do it this way. Just show you. So I could just subtract, right? Just go, so 26 minus, I could go 14 is equal to negative 2b plus c, right? So just do this, and then just change all the signs. Negative 14, positive 2b, negative c. That's kind of a reason that I wanted the negative c, right? Because what do we know? b plus c is negative 1, and 2b minus c is negative 14. So we got a system, right? We got a system of equations. 2 equations, 2 unknowns. We're just going to add them together. So I'm going to get 3b plus c minus c added 0, right, is equal to negative 15. So b is negative 5. Now we know that b plus c is negative 1. b is negative 5. So negative 5 plus c is negative 1. So c is 4. And our solution is negative 5, 4. Actually, it's not really an ordered pair, is it? So never mind, it's not a point. The solution is, what do they ask us? Yeah, determine the values of b and c. What does determine mean? Show your work. Okay, and then I should not have written that as an ordered pair. We're not really solving for a point, we're solving for values of b and c. Okay, now if you wanted to check that, you could go into your graphing calculator, you could enter 3x squared, 3x squared minus 5, well, let's do it. 3x squared minus 5x plus 4, right? Yeah. Okay, so go y equals, clear that. So 3x squared minus 5x plus 4. I don't want to graph that, right? But what I could just do is go look in the table. So there's the table. So at 1, we've got 2. And at negative 2, we've got 26. Okay, huzzah, right? It checks. Okay, you could also graph it and then just go second calc value and put in a value of 1. Yeah, okay, let's do that. So I'm going to say graph, because it's not going to work terribly well here, right? So, okay, so I'm going to go second calc, whoops, hang on. Second calc value, and I want x as 1. Comes back with 2. Second calc value, and I want x as negative 2. And it comes back with 26. Okay. So it works. That's it. Is that it? Nothing left on your pages either.